Hello and welcome to the next lesson in the unit. We're looking at what we call the ambiguous case. The ambiguous case. What's the learning goal? I can explain why the ambiguous case results, and I can identify the different cases of the ambiguous triangle and solve the questions accordingly. So basically, I understand ambiguous case and I can apply the skills necessary. So here we go. What is the ambiguous case? Well, the problem arises because our sine function always wishes to please us. So, as you know, internal angles of a triangle add to 180 degrees. When we talked about the cast rule, the following steps occurred. So I'm just going to quickly give you the why we have problems. So if we look at cast rule for cosine, and we start with that. All right. And we said that if it appears or it is in quadrant number 2, over in this quadrant here, we know that the cosine function is going to be negative because only sine is positive. So if I was to construct a triangle here, like that, all right, this angle is greater than 90 degrees. So I'll just say theta is bigger than 90 degrees. So if we were to use the cosine law, because I'm talking about cos to start off here, if I was to use the cosine law, so a squared equals b squared plus c squared minus 2 bc cos angle A. So that's my angle A. What happens when cos is greater than 90 degrees? Well, we know that cos of an angle bigger than 90 degrees, so from 90 to 180, will equal some negative number. Which means then that this term here would become negative, which then means negative subtract a negative. We would have b squared plus c squared plus 2bc cos A would be our end result. So it understands the cosine law is very, very smart. It knows, hey, I have an angle bigger than 90 degrees, and I'm going to compensate for it. Okay? The problem then with sine law, sort of the same setup here, using the cast rule. Again, if I'm in that quadrant, hey, what's happening? So there's theta. If I build a triangle out of it, just to emphasize a point here. Well, with sine law is positive in both quadrants. Okay? Sine law is positive in both quadrants. And we have seen that sine of 60 degrees, for example, which would be in quadrant 1. So let's say I go 60 degrees. I go right here in black. I say that's 60 degrees. If you calculate sine of 60 degrees, what happens is that you get 0.866. So 0.866. What happens if I do the sine of, I'll do 180 minus 60. So that would be the theta up here now, because if I did 180, I backed up 60, that's what theta would be. So 180 minus the 60. So I'd be calculating the sine of 120 degrees. If your calculator's handy, sine of 120 is also equal to 0.866. So what happens is that if we set up our sine law, sine A over A equals sine B over B, we could end up with sine of 120 or sine of 60 in that first fraction, for example. And the question is, though, the sine law then can't tell you, that, hey, sine of 120, the triangle is going to look like this. And if it's 60 degrees, the triangle is going to look like this. Sine law just happily goes along and says, that's the triangle. Every time it goes with the smaller angle. So when we get into situations where the angle is greater than 90 degrees with the sine law, there are two possible triangles, and I drew them up here. So our two possible triangles, it could be this one, or it could be, oops, this one right here. And the sine law doesn't tell you this. It just says, hey, I can get an answer for you. This is the answer every time. It's a small angle. When there's actually two solutions, and where we really run into a lot of trouble, is when the yellow one is actually the one we want. We're calculating this. This is the one we really want. But again, sine law will spit out this one every time because it's always happy. It picks the smallest one for us. It thinks it's doing us a favor. So that's the problem. That is our main focus here, is this exactly right here. Ambiguous means that there's two ways to interpret the information. It's kind of, it's flawed in the sense that it could be the bigger triangle or it could be the smaller triangle. So that's what the focus is dealing with. Sine law when angles are greater than, or situations where this occurs. All right? So that's what the note's focusing on. So how do we handle the ambiguous case? And this is the key right here. These are going to go on your cheat sheet because you're not going to memorize this. So for three cases, triangle ABC is going to look like the one I've got there. Our three cases are listed down the side. So you'll have this on your printout. So what happens if B sine A is greater than sine A? So what I'm going to do is, if you want to give yourself a quick sketch here, I'm going to pull this down here. And I'm looking at this particular triangle. So I'm going to unlock it for a second here. So B sine A. So off to the side, I just want to make a note here, and maybe I'll use the top triangle here. This is the angle in question. Okay, so that's angle A. So what does B sine A actually calculate? So this is side B, side C, side A. So B sine A, what that is going to do, it's going to find the altitude of the triangle. So I'm going to do that in a different color. So this green bar right here, all right, the altitude of that triangle is B sine A. All right. Why do we know that? I'll quickly go through and show you the trig. So if I take the right angle triangle here, A would be my reference. Then I would have opposite. So I'll do it in red. Opposite, adjacent, hypotenuse. So I go ahead and calculate it. So opposite and hypotenuse, so I'm going to be using sine of theta equals opposite over hypotenuse. So I'd be doing sine A, the angle in question. My opposite side is actually the height of the triangle, or altitude, divided by the hypotenuse, which is side B. So height is equal to B sine A. All right? So we're really calculating the altitude of that triangle. Altitude. So we are going back over to case one. We're going to compare the altitude with side length A. Compare, must be greater than side A. All right. So what happens if the altitude is longer than side A? Well, this triangle would not be possible. So here's my altitude. So the green, that's my B sine A. So that's the altitude. I showed you how it works over to the side here. So this is the calculation. This is the y over here. All right. So we now know we're going to accept that altitude is B sine A. Okay. What happens if it's bigger than side A? Well, side A, I'm going to play with its length. So if I went over here, this would be an example right now. So you can see me swinging the arm. Here's side A. Whee! Okay. So right now, where I have it left or drawn, that's when B sine A is equal to A. If it's shorter than B sine A, then what happens? We end up with this side length A that never ever touches side B. Okay? Which means that we cannot create a right angle triangle. See? Whee! So unless I can get down to B, I can't touch it. If I can't touch it, that means that it never ever creates a triangle. So the answer here, if B sine A is greater than A, no triangle, or sorry, no solution, I should say, no triangle. I was going to say no triangle is possible. That's true as well. But no solution is possible. And that's because the triangle is just is constructed, the information given just doesn't allow us to build a triangle. All right. Case two. So same idea. Take my triangle down, ungroup it so I can play with it here. So again, we're talking about altitude. All right, so my altitude is equal to side A. So side A is over here. Here's that altitude. All right, that's the B sine A. So what happens when that A length is just that length? Well, if I was to keep it that long, like a pendulum, the only place it touches side AB is right here. It's the only place possible. What type of triangle does that create? The only way it meets it at a right angle. All right, so the dashed line is kind of the swing path. One point of contact. So 1 point of contact. And this situation is actually just as preferable as the first one. First one's nice because you're done if you can prove that. But this one, it creates a right angle triangle. Creates a right angle triangle. And there's only one solution. All right. So what that would mean then for us, if we were solving this question, and I got some examples coming, first of all, I wouldn't have to use sine law. I just got to use SOHCAHTOA because it's only one possible triangle for that situation. And it's going to be a right angle triangle, so there's only one solution. That's it. All right. Last one we're going to look at here. Bring that triangle. One more sketch. And this is the bad one. This is the ambiguous case right here. So again, I'll sketch out the altitude. All right, and this is of course a side A. So here's the altitude drawn in. One more time, B sine A. All right, so now I'm going to make it longer. So it's going to look like that. All right, if I was to swing it, and I got to shorten it a little bit. If I was to swing it, there are now two possible solutions. So I'm going to make that line a little bit longer. B over here. So if I try to keep it the same length, I'm going to cross there and across there. So my path looks like that. All right. So if I follow that path, there are now two possible solutions. There's solution one and what do I want to do here? Let's clone it, I guess. Put it up here. And there's solution two. So I have two possible triangles. I've got, where's my highlighter here? I've got this triangle, and I also have this triangle possible. Whoops, not even close to the line I want it down like that. All right, so there's two possible triangles in this case. So if that's the problem, we have two solutions, and we have to use sine law for each. All right. So those are the three situations that arise when we are using the sine law here. All right. So when we go through the examples, we're going to be doing this test. This is a test or a check. So we're going to start with this every time. All right. And we're going to decide which situation is it. No solution, one solution, two solutions. And from there, we're able to solve the triangle. So the last video is just going to be doing examples dealing with this.